Hi, Sportster Paul here. We're in our Suffering with Software series, and we're doing VisualMill today, made by mecSoft out in Los Angeles. The first impression, it hadn't been very good. It's not been stable for me. It's been crashing. I changed stock allowance. You know, they always want to put a stock allowance on it. I don't know why they don't want to cut to the model. I change it to 0, then I go change some other stuff. It changes to a 1 and leaves an inch and makes these crazy toolpaths. It's crashed several times. Now this is on my machine, which is Windows 7, not even supported by SolidWorks anymore as of a couple months ago. It's a laptop. It's an HP ZBook 15 laptop. It's got a Quadro card, so it's got, you know, a CAD kind of high performance CAD card in there. But we'll go through it and probably play with this thing. You can't save it. That's the whole deal with the demo program. But we'll play with it probably until it crashes. We'll see if you know, my fumble fingers in this Windows 7 will crash it again. So the other things that gave me a bad impression, they'll say, you know, I wrote them, hey, are you a perpetual license? Because CamWorks, the free SolidWorks CAM, which is CamWorks, it's not perpetual. You got to pay maintenance. So yeah, we're perpetual. And then you watch a bunch of their videos, and it turns out, well, their G-code simulator, that you have to be paying maintenance to have the G-code simulator work. It's a separate package, but you know, it's that same thing of like, I might be able to retire one day, and I want to play with all this expensive software that I've spent tens of thousands of hours learning, and I don't want to pay maintenance because it'll be fun and hobby projects and just, you know, maybe making more videos. So that kind of left me wrong. And then when I did the installation, oh, and this is a factor in the crashing I've been having. It failed the installation when it said, oh, it wants to install 2 Microsoft Visual C++ versions, you know, like a 2013, which alone bothers me. It couldn't do one because it said, oh, there's a newer version already in. So we failed to install one of the 2. But you figure, well, if it's got the newer one. And that's the other thing that I got some really superb software buddies, and they never think very well of Microsoft tools. One guy calls it a memory leak distribution system. And that's with the crashes. You know, they don't deallocate the memory right, and it grows and grows until, boom, it brings down your whole machine. So well, I haven't had that happen. I haven't had a blue screen of death, but the program's crashed. SolidWorks crashed several times. So let's go take a look at it. Oh, the last thing that kind of put a bad feel in my mind about when I did the install, and even though it said, well, we can't do one of the Visual C++s, fine, you know, close out of that. It kind of takes over your SolidWorks. It didn't delete the add-in. It disabled the CamWorks, the SolidWorks CAM add-in at both startup and regular, and enable them both at startup and running. So the next time I open SolidWorks, I get this splash screen and I'm stuck in VisualMill. And it's like, wait a minute. And I must have panicked because when I looked to find the add-ins to kind of calm this all down, it didn't look like I could find the add-ins. Probably just simple panic. But let's go look now. Let's go look at the SolidWorks. I've kind of fixed all those issues by going in. You say Tools, Add-ins. I've left the SolidWorks CAM unchecked at startup. You got to watch this. Unchecked to run. And then they put down here Visual CAM. I don't want it at startup, right? I'll decide when to run this. So you say, okay. And now it gives you that same splash screen that it gives. FreeMill it installs just and runs. There's a FreeMill that you can make G-code totally free. We'll play with that next. Then the CAM demo. This is where you can go to the higher packages, that, you know, the paid for packages. So you go CAM demo. I want to do a mill. And then premium, it was so fancy, like for mold making and stuff. Professional is a full 3D package. And you'll see some cool stuff that I learned about that. Then it looks like what you do after you select that, you re-hit mill. Now it's in its thing, right? It's ready to do its thing. So when I open, this is my buddy's test part, purposefully made to confuse CAM systems. Let's see if we get our little tab. This file contains CAM system preferences. Would you like to use them? That might be left over from the SolidWorks CAM. I decided just to say no. Oh, look. Not only do they run the VisualMill stuff, the tab, it's already lit up the tab. Here's the model, right? Breakout hole here, breakout hole here. These are tapped holes, 1/4-20 tapped. It's, I think, 3 inches by 4 inches by 1.5 inches, or an inch, that's right. So these breakouts, he's smart. These radiuses aren't for a 1/4 of an inch tool, it's for 0.26. So it means the tool doesn't stop hard in the corner and then keep going. It actually runs around. But let's play around a little. Let's go back into the VisualMill. Okay, machine 3-axis. So I think these, at least, their dialog boxes don't disappear because I got 3 screens, 4 actually. It always opens this dialog box off on the free screen, which is kind of nice. It's pretty sweet. They've done a lot of good stuff. So here it is. See, I had the hardest time. How am I going to show you folks this? It's like they've got there's an arrow here. I found out that's these down here. There's except they don't work with this dialog box open. World CVS, so you can erase those. I have did that come with the part? I'm not sure. But I know when I go into machine, and I know that if I say rotate about the Z-axis twice, once, twice, say OK, and then let's see which one I really want. No, not that one. So now I've made the part. I'm going to make it in a mill in the vise like this, with this surface here facing me. So now that's saying the mill agrees positive X in my Avid Benchtop Pro. Love this thing. Positive X now is off to the right. Positive Y is down. And then for positive Z is actually downwards. But from the limits of orthogonal rules, I don't know. The arrow always points up. The other cam, SolidWorks cam. So that's good. We got a machine. It's 3-axis. There was other stuff in that dialog box about definitions. 3-axis, tool change points, sizes. Nothing too critical for our little demo. So then the post, they'll let you save this file if you don't make any toolpaths. So I went and changed, double click, and it lets you choose all kinds of posts. It doesn't have a Mach 4 like I've got, but it's got, come on. It's got Mach 2. It's got Mach 3 with automatic tool changer, Mach 3 for inches, Mach 3 for millimeters, Mach 3 for a Sureline mill, which I think one of my buddies has. Let's go back to inch, say OK. And in general, I like the layout and the thinking. I didn't like SolidWorks CAM because now you're in the feature tab. Oh, now you're in the operation tab. But sometimes we'll jump you over there just to confuse you. This is more linear, like my brain works. Nice linear operations. So we got that. Now stock. Now we might have to go around a couple times with this. Double click on stock. Maybe I can, here. You can make cylindrical stock, part offset, extruded stock, stuff like that. What's part offset do? Radial offsets, more 3D. I think they're big on 3D. Stock, part box stock just makes the stock as big as the part, and I obviously don't want that. So now it gives this thing, and unlike SolidWorks CAM, they let you go give the overall dimensions, 4.5, because I want meat on both sides, 3.5, and then because you can only buy stock in 1.5 thicknesses, say OK. There it is. And that same dialog box, with these buttons here, lets you put it in any corner. Now, you can tediously go up here and move it around, and that's what I'll probably end up doing, but there's also an align function. See, bang, instantly. It aligned it now. This is what I dreamed of with SolidWorks CAM. VisualMill, you just say, no, align this thing, and let me show you the dialog box. Align it at the top. So the stock now is aligned at the top. I wish they'd have an offset there, but XY alignment, put it in the center, right? Center this thing, which It was easy to do with nice, even, 4-inch wide, make it 4.5, leaves a 1/4 inch. But your part won't be these nice round numbers. So this is fantastic. This is delightful. You say, okay. And now you say, okay, now all I want to do is drop the part down 1/10 of an inch. So I got stock up here to mill off, and I want the most of the stock on the Z down here so I can hold it in the vise, right? First thing a machinist thinks of, how do I hold this? So I said box stock, it goes back there. No, I don't want to, and it's no crisis. You can go with these things and move it around. But good gosh, the way I finally fixed it, I think I did a file, save, close it, file, open it. Here it comes. No, we don't want the CAM data. There's the stock. Now I think, if I did this the same, now it leaves the stock where it was. It's got this lingering, where something that you did in a dialog box before, you'll type a number into a dialog box, into one of the little tabs, and then you change focus where you expect it to update. It won't. You got to use the arrows and move it around to get it to take. So that's another little flaky thing. And so now that it's working the way we want, we can go Z, wrong direction. And since they happen to go in 1/10 inch increments, that's just what we want. Thank you so much, VisualMill. We'll say okay. Now we got the stock where we want it. We got the part. I like this better than the CAM works. Of course, that was the free CAM works in SolidWorks. Whether there is limited normally. I love the fact that there's this fixtures tab, because that tells me I can put in clamps and maybe a vise and stuff like that, and it'll at least show me if I go bombing a tool. Every machinist I know has broken a tool going over a clamp, somehow gotten across it in their lifetime, right? So setup 1, I think we do work 0 now. This is where I want to hold it in the vise now. You always want your work 0 to be on the fixed jaw of the vise. Otherwise, little variations in the part are going to change where that 0 is. So the fixed jaw is going to be in the back here. The movable jaw of the vise will be up front. So this was easy too. Set to stock box, and then it gives you the choices here. Oh no, I'm sorry. You don't get the point at this one. You can tell different programmers did it different. You can go west, east, center, north. So that's exactly what we want. X is red, positive X towards the right, positive Y to the back. That's exactly like my machine setup. Say generate, and it's happy. That's just what I want to see. Now let's go play with this. Okay, that turns that on and off. And this is the one in the center that I couldn't get rid of. Well, you learn something every time you play with it. 10,000 hours, Malcolm Gladwell says. Now, I want to show you something. It went back into setup, darn it. Because I did the premium, I didn't do premium, I think I did professional level. I was playing around and said, well, okay, rather than doing everything separate, face it, perimeter, let's see what happens if I just say horizontal roughing. And it opens this dialog box. And rather than, it wants you to select geometry in this, what kind of geometry here. And then when you select that, it goes and gives you, here it lets you go pick things. Let's not do anything. Let's just say generate. Now first it says, oh, you got to have a tool. This is another thing. I was surprised there weren't any standard tools in here. There's no tools. Maybe because this is the demo program, right? Edit, create a tool. Not too bad, except they default to a ball mill, which screwed me up once. You got to go up here. Say, no, I want a flat mill. I use big ones, shank diameter of 2.5, tool diameter of 2.5, flute length. We want the flutes long enough. 1.3 will mean I'll be able to do the sides because it's 1.2. Tool length, let's stubby it up as much. That's the other problem. Look how they define tool length. From the bottom of the collet to the tip of the tool. Do you know a tool manufacturer on earth that would call their tool length that? This is what SolidWorks CAM, aka CamWorks, calls protrusion. All right, I understand if you want to model this, but that was a kind of a in their own world programmers, not the way a machinist would talk about how long the tool is. So I did that. Okay, there's our flat end mill. Now we'll go back and, there's speeds and feeds. You can go play with all of this, but what I got a kick out of, you just say generate, it thinks, bam, did the whole part. Now, here is where, oh, wait a minute. First thing I love about this, you can just move stuff around, put the word 0 in front. I don't know why, it just seems right to be there. Parameters, double click. It always wants to leave, these are tolerances, 10,000ths of an inch tolerance, inward tolerance, outward tolerance, and it leaves 25,000ths of material. And I'm like, well, I don't want that. I learned you can't set this too small. Don't set it to 5/10. It crashes the program. But it's like, no, I want this. It's a precision machine. Well, of course, this is roughing. So the first thing I tried, being frisky, well, let's go to 0. And then the other aspect for the cut levels, top. Okay, so the top it's doing the stock. The bottom, I don't want to go to the bottom of the stock. All these programs want to cut through your vise. I've never seen anything like it. I want to go down, oops, wrong way. The part's 1 inch. Or no, see, they're going from the top of the stock. So we gotta, okay. So there, it's right at the bottom, but I want to overcut it a little so that when I face off the bottom, there's not this razor sharp edge. So let's add our 20,000ths. There's 20,000ths. Say, see, and this is what's weird. Let's go look. See, I took focus off. Oh, it actually worked this time. It actually moved it down 20,000ths. Now say generate. Thinks perfect, right? Bottom, it's cutting just a little below the part. It's doing all this stuff. But now remember, let's see if it remembers. This is where I kept having it fill in the boxes. No, it remembered now. Because what it's been doing to me over and over and over, it'll put the number 1 in the stock and make these giant toolpaths that don't make any sense. Maybe just because of Windows 7, don't know. Say cancel. Then I also like, they got a big tab here. What's mill? Machine job, turn. Oh, okay, it changed. Mill turn. Oh, okay, they're letting me profile nest. Now we just want to mill. Go over here to simulate. Oh, I've turned the command manager off, by the way. Enable command manager. They give a thing and put all of their building, they call them browsers. It's like client. That Altium had this, client server kind of nonsense. I prefer the vertical space, so I disable the command manager. And as you can see, there's always a way to do it different. Speed this thing way up. Say play it. Zing. Watch this baby go. There it is. It's actually roughed out around this little bottom pocket down there. And you're like, wow, that did really good. Oh, here's the other thing to check. It's hard to see. You see this little blue toolpath right there? There it's going. That's key because that means it actually went in and did around here. So that's telling me, hey, it's at its 0. It's doing mathematics. And so you say, oh, now it's got that same thing like SolidWorks CAM, the compare button. Oh, wait a minute. It's got, I think this is a gouge. Blue obviously means you left stuff. Okay, wait a minute. So it did the sides true. It put in a little gouge here, a big gouge here, a gouge here, it's confused. So, operator error. I'm sure there's some right way to do this, but I haven't figured it out. Cancel. Where are we now? Simulate. Go here. This was the other thing. If you go toolpaths, the first time it opens like this, and you're like, how do I get back? Where is it? Oh, you got to know that, it's just because of the space. You got to do that, and then you can see where you were. And what I love doing is you just bring toolpaths down, so now you can see the operation. It's going to take almost 2 hours, 1 hour and 53 minutes, but you got to love them because they're making the time right up front, totally visible. Fantastic. I love this. So I played around. Okay, parameters. Let's leave. What is it? Point. Is that a comma? Point. Oh, let's add 20. I'm showing you. I'm sorry. I should show you. You can't see that screen. Here, generate. It's thinking. Bam. Did it. Simulate. See, now you can play it, and it'll go real slow if you want. Well, not real slow, actually. It's still pretty fast. It's doing its thing. But now I told it to leave more stock everywhere. Pretty cool. And let's see if we compare. See, at least the gouges are gone by leaving all that material. So then my thinking was, well, okay, I can spend 2 hours while I'm eating Fritos or something, and the thing will carve the bulk of the stock off. Then I can just come and do finish passes. So that's an interesting approach to doing this. Meanwhile, there's no delete, but you can cut things. And we're still in simulation. I've learned this problem when it shows the block like that. So let's do it a little different now. Let's do 2-axis. We want to face. I've learned, come here, don't select anything. I can't remember if you select this or not. Say generate. Do you want to use stock silhouette? Oh, I should have checked that. To face, yes. Bam, look how smart this thing is. It went all the way out to the edges of the stock and did its thing. Now, what I don't know, I think in Z it actually obeys. Let's simulate real quick. Go to end. Compare. Yeah. So at least for Z level, it went down to the mathematical surface of the solid model. Good. It's green. We're happy. Green is good. So now we faced it. Then I'm getting 20 minutes here, 21 minutes. So let's do what caused me some problems before. I figure I want to do the perimeter. I only want to do it down to the bottom of the part. I want to leave meat here. I don't want to go into the vise. I've got it decked. So let's do a 2.5 axis, whichever, and let's do a profiling. And I'll save you all my practice runs. At first I said, well, pick the 4 simple ones down here and say, well, that's the bottom. And you can, and it will eventually give you toolpaths that are sensible. But you can't go underneath that bottom. So what I ended up having to do, let me get you the thing. He said, okay, select curved edge regions right there. Then I had to go on the top and select these for the perimeter. And it'd be interesting to see how it handles faced before facing. I think that's all of them, right? You say yes. Oh, I made a mistake. All right. I love the way they put cancel right next to Windows has done that, since Windows 1. Let's put the cancel button right next to the do it button. Brilliant. Okay, so now we got it. Now we're back here. It's defined all these perimeters. The tool is going to be what it was. There's only one tool defined. What, as a newbie, like, well, let's generate. I want to see toolpaths. What does this thing think it's doing? So I go generate. It's done one toolpath, which will leave corners, right? The stock is thick enough. Can I show stock? See, it says it'll show stock, but it won't. All right. So I know from messing with SolidWorks CAM, if it just does one perimeter around here, it'll leave little corners here, little posts sticking up in the corner of the stock. So that's not too hard. It wasn't too hard to figure that out. Go to double click on parameters. We get parameters. Oh, it's remembered. It's now doing 0 and 0.01. I tried 5/10. It blows up. Where was this? Cut levels. This is what we want. The location of the cut geometry is at the top. The depth of the cut. Okay, so if that's at the top, I know I want to go. See, it doesn't show you anything. That's a little unfortunate. 1.2. No, 1.02. 1.02. Generate. This is when it starts blowing up. I'm glad we caught this. Just so, in case people think I'm crazy. Look what it did. It's decided parameters, double click. It always opens on the free screen, which is good. I mean, it's not fighting me like SolidWorks CAM was. SolidWorks CAM, they just disappear. I got to go find them. What they did is they went into cut parameters and they changed that 0 to a 1. change it back to a 0 and say generate. Okay, now it did this. So, and this is the seesaw, back and forth, back and forth. Total cut width, 1 inch. See, it loves putting ones in the boxes. There's some buffer overflow or memory leak. The total cut width, now I had problems with this. I tried and tried. It's like, look, I only need a 1/4 of an inch. So let's say that the width is 0.25. Well, that's taking forever, isn't it? 0.25. Steps per cut, and it's smart enough with these sliders. Steps per cut. See, this is the step over. Let's do half. See, this is kind of cool, the way they can. So they'll do half. Cut levels, I think this is dialed, right? We're happy. It's going a little underneath, just like we want. Say generate, and it screwed it up again. And this is what I mean by it's unstable. I can't use it because it keeps doing this. What I found sometimes helps is, you can tell how much fun I've had. Put a number in here instead of the 0 that seems to confuse it. Say generate. Now it acts like I want. And I sure wish this show the stock button would work. It's supposed to. Stock box. Show the stock. Don't show the stock. But the stock goes away here. But let's just kind of eyeball it and see if we got these corners. I think so. What can we do? Tricky. We'll put the corner, hold control key down. We'll put the corner right up, oh gosh. Put the corner right up there. Sorry, I'm being so tedious. This is ridiculous. Right under the bar, and then we'll say parameters. Yeah, plenty. Now what I can't do is say just, get the corners, right? And I'm sure there's a way to do it, but I never could. But you've seen how it's blowing up on me. I think we'll kind of call it quits. This is impression 1. You saw the kind of problems I'm having, but also the promise of this. See, this is what happens. I think there's more machinists on the payroll here. They're not outsourcing. Maybe they are. But there's some machinists that kind of like, this is the flow and this is how you mess with stuff. So I'm actually excited. I think it's a great program. It's just I can't use it because it's unstable. And that might just be because of my Windows 7. All right. And then so we'll do a second impression, third, fourth, as we go through. We got the perimeter. Oh, we got to show you the fun part, right? Hang on. Simulate. Oh, wait. Parameters. See if we can get away. No, I want this to be true. I want it to be 0. The cut levels always seem to be true. Let's say generate. I think, see, always got to. Sometimes I wish they just leave dialog boxes up permanently. It left it 0, so you can kind of sneak into it. Let's cancel. Now let's go simulate, and let's go to the end. Bang. So let's do compare. Perfect, right? Green is dead on, within what? 3/10,000ths of an inch. And we hit it. These are the decks of the part. This is the part we haven't done. So that's our fun for today. We'll get the second impression. I don't want to make these too long, bite-sized chunks. There's other choices in the 3 advanced clear flats. I use those I use that function to clear this flat. So there's some real appeal. The pockets, I still have problems getting mathematical accuracy. I think I've set it to say, no, I want to see green everywhere in here. I couldn't get it to happen. We'll go through that next time. And then by the time, see, I can't save this. So next time I'll get this far and then turn on the camera and we'll go from there. And I never have been able to put tapped holes in this thing. It crashes when I try. But as the new guy, clicking things like crazy that don't make sense, that's when programs crash. Because software is too complicated to test every idiot's click. It's a shame, but it's true. So that's VisualMill. We're having fun with it. I'm kind of excited. It shows there's a new way of thinking that I prefer to the CamWorks thinking. I don't like that automatic feature recognition that didn't recognize the features right once. And when you, this promise of, oh, you just change something in the model, it'll automatically change the toolpaths. I don't like that either. And I wonder what VisualMill claims about if I changed some dimensions here, if it would have followed them. I assume if you define to a face and that face moves, then it'll automatically change. We'll try that next time. Give me something to practice on, okay? So I hope you had fun. We'll see you next time, okay?